Okay, welcome to the college entrance test reviewer on common circle area questions. Okay, now these are absolute mainstay of all college entrance tests, and if you know your stuff, they're not that hard. You just have to focus on the question and making sure that you use the right units and answer the question as they ask it. So question number 1, find the area of the circle sector shaded in orange. That's that, and if anybody wants to do that question, I'll just pause the video now. Okay, so this is pretty much as basic as it gets. We know there's 360 degrees in an entire circle, and this is 30, so the area of the circle sector shaded in orange is 30 over 360 times by the area of the whole circle, which is pi times 4 squared, which equals 16 pi over 12, which equals 4 pi over 3 centimetres squared. Remember, this is centimetres, so the area centimetres squared. Okay, that's a nice easy start. Right, so question number 2. If anyone wants to pause the video to do this, do it now. Okay, now this one, they're asking for the area of the circle sector shaded in blue. Don't be confused by that. So they want this bit rather than the orange bit. And also they are giving the angle in radians rather than in degrees. So what the best way to do probably for this one is to do the area of the whole circle, which is basically pi times 4 squared, which is 16 pi centimetres squared. That's the area of the whole circle, and then we just take away this bit, which is basically pi over 6 over 2 pi, because there's 2 pi radians in a circle, times by the area of the whole circle, 16 pi, which equals, where are we? Pi over 6 over 2 pi, pi over 12, that's 4 pi over 3. And so therefore the area of the blue bit equals 16 pi take away 4 pi over 3, which equals 44 pi over 3 centimetres squared. Okay, and that's the second question. Let's have a look. Question number 3. Okay, so pause the video if you so desire. Okay, now this time they are giving us the circumference rather than the angle. So we're going to use the same ratio method. Well, the circumference of the entire circle is pi times d. That's the circumference of the entire circle. And the radius is 4. So therefore the circumference is equal to 8 pi centimetres. And so therefore this sector here, the circle sector shaded in orange, is going to be pi, which is the length of that sector, over the entire circumference, times by the area of the entire circle, which is pi times 4 squared, which equals, which equals 2 pi centimetres squared. So the area of the circle sector shaded in orange is 2 pi centimetres squared. Okay, question number 4, getting a tiny little bit harder now. Anyone wants to do this, pause the video now. Okay, so basically what we're going to do, we need to find this bit in orange here. So first of all, we need to find the area of this sector here, and then we need to find the area of this triangle here, and then we take one from the other, and that will give us the orange bit. Okay, so let's first of all look at the sector, and it's exactly the same. We know that the measure of the minor arc AB is pi over 4. That means that that angle there is pi over 4, and so basically we know that the area of the sector is pi over 4 over 2 pi times by pi r squared, and the radius is 3, so that's pi times 3 squared, which equals 9 pi over 8 centimetres squared. That's the area of the sector. Now let's have a look at the triangle. Let's just try and draw this triangle here. Okay, so we know that this is pi over 4, and we know that these two are both, the radius are both 3, and so therefore we can use the sine rule to find the area of the triangle, and the sine rule is that the area equals half AB sine C, where this angle here will be C, so the area equals a half times 3 times sine of pi over 4. Now pi over 4 is 1 over root 2. This is one of the very well-known signs that really you have to know on these things. So basically the area is 9 over 2 times 1 over root 2, which equals 9 root 2 over 4. Just bringing the root 2 and multiplying both sides, top and bottom, by root 2. Okay, so we have the area of the triangle is 9 root 2 over 4. So therefore the area of this orange segment is just one take away the other, which is basically 9 pi over 8 take away 9 root 2 over 4 centimetres squared. And we can't simplify that because that's pi and that's root 2, and we can't add and take them together, so we can just leave that as it is. And that is the area of the orange segment. Okay, question number 5. Okay, so find the area in orange between the circle and the x and y axis there. Okay, so if you want to pause the video to do this one. Okay, so basically, people surprisingly find this one difficult, but if we just draw a little square here, we know that is 5, and we know that is 5 because the circle touches the x and the y axis. So we know that the area of the entire square here is 25. Doesn't actually say what the units are, so we don't need to give a unit, so it's 25. And so therefore, the area of the orange bit is going to be equal to the area of the square, take away the area of the segment. And the segment here, this bit here, the segment, sorry, I haven't drawn that very well. The area of the segment is basically just a quarter of the area of the circle, because that is 90 degrees. And the area of the circle is pi r squared, which is 25 pi. So therefore, the area of the orange bit is going to be 25 pi, which is the area of the circle, divided by 4, that's the area of the segment. Take that from 25, which is the area of the square, and that gives us the answer to what the area of in orange is. There's no units given on this, so we don't need to give a unit. Okay, let's have a look at question number 6. All right, these are fairly common when you have a shape inside a shape. So if you want to do this one, pause the video now. Okay, so the area in orange is basically the area of the big circle, take away the area of the small circle. The only thing to note here is they're giving us the diameter here, not the radius. So the area of the big circle is pi times 4 squared, because the radius is 4. And the area of the little circle is pi times 3 over 2 squared. And this is in meters, so the units, be careful of those units. So basically that equals 16 pi minus 9 over 4 pi, which equals 16 minus 9 over 4 pi meters. And we can simplify that slightly to being 55 pi over 4 meters squared. Sorry, my bad, meters squared, not meters, because it's an area. Okay, so the answer is 55 pi over 4 meters squared. Okay, that's question 6. So look at question 7. Again, very slightly more complicated. Pause the video if you wish to do this. Okay, good. So basically, the area in orange is the entire circle. Take away these 3 blue circles, and they tell us that each blue circle has a circumference of pi. So they're telling us what the circumference is. Okay, well, clearly the area of the big circle is equal to pi times pi times 5 squared, which equals 25 pi centimeters squared. That's the area of the big circle. Now the area in blue, so if the circumference is pi, they tell us the circumference is pi, then basically pi times the diameter of the blue is equal to pi. So therefore the diameter of the blue is equal to 1 centimetre. So the radius of the blue circle is equal to half a centimetre, and therefore the area of the blue is equal to pi times the radius squared, and there are 3 of them. And so basically the area of the orange bit equals the area of the big circle, which is 25 pi, take away 3 times pi times a half squared, which equals 25 pi minus 3 pi over 4 centimetres squared, which we can simplify slightly to 97 pi over 4 centimetres squared, and that is the area of the orange bit. Okay, now finally question number 8, getting slightly more difficult, this one. So find the area of, oh, by the way, pause the video if you wish to answer this one. Okay, so finally, find the area of the rectangle inscribed in the circle. So we want to find the area of the blue bit, given that the ratio of its sides is 5 to 12 and the radius of the circle is 26. Okay, now, so that means that the ratio of the sides of the rectangle here is 5 to 12, and the radius of the circle, there's the centre of the circle, the radius of the circle is 26, so that means that that bit is 26. Now if we look, let's just do a different colour. If we look at this triangle here, that is 52, because the radius is 26 and there's 2 of them, so that's 52 centimetres. And this is a ratio of 12 to 5. So this isn't, that's not its length, that's its ratio of 12 to 5. So clearly here we have one of the famous right angled triangles, which is a 5, 12, 13 triangle, i.e. from Pythagoras, 5 squared add 12 squared equals 13 squared. And the other famous triangle, by the way, is the 3, 4, 5 one, which is 3, 4, 5. 3 squared add 4 squared is 5 squared. You see these triangles all the time in exams, so it's well worth just knowing them. This one clearly here is another 5, 12, 13. So they're saying that the ratio of these is 5 to 12, and the length of this third bit is 52. Well, that means, therefore, that we can say that the if that is 52, this means that this here is going to be length 20, and this here is going to be length 48. Basically, that would give us a, oh, sorry, I don't know why it came like that. That's going to give us a triangle 20, 48, 52, which is basically that triangle with all of the bits multiplied by 4. Apologies for that. And so therefore we know that the area of this here is going to be the base times the perpendicular height there, and then, because there's 2 of them of course, the area of the whole rectangle is going to be equal to the base here, which is 20, times the perpendicular height, which is 48. So 20 times 48 equals